Hey everyone, welcome to another training video in Kusto Query Language series. This training video is about the KQL advanced queries and about the join operator. Under the advanced queries in Kusto, we have several operators like join, union, or we use subqueries, and these topics are quite vast, so that I thought of doing a separate video on each of these concepts so that we can discuss these topics at length. My name is Navneet Kumar and I'm a Microsoft certified trainer. The learning objectives of this training video are understanding the advanced KQL queries and the join operator in KQL, how to use it. If you already have the background of SQL or other database services, you may be familiar about the use cases where we have to collect the data from various tables and we have to join it into a single table or a report. This is required when we deal with large data sets or we have a requirement of collecting the data from different tables. Well, that is the job of this join operator. The join operator in KQL is used to combine the data from two or more tables based on a common column or the property of the records that we are looking for. It is similar to SQL joins, and KQL provides the different types of joins that we have in SQL as well. These are like inner unique, which is the default method or default join type. Then we have inner, left outer, full outer, right outer, left semi, left anti, or right anti. We have various join types or kind that we used when we collect and merge the data from two different tables. Let's have a look at these different types of joins in KQL. These different types of joins in KQL are left outer. As you see in this left outer, we have the properties, all the properties, or you can say all the records selected from the table, from the left side table, whereas the right side table will have only the matching records with the left, or matching keys you can say with the left. Then we have full outer. We have where we can collect the data from both of the tables. Then we have right outer, left semi, inner, right semi, left anti, inner unique, and right anti. If you already have worked with SQL, then you must be familiar about this concept. But if this is new to you, then excuse me about this image that I have brought up over here. Let us understand that with examples and the each of the join type. Well, I have created a table for this explanation of all the different types of joins. If you look at this table, I have created the two different variables using this let statement in KQL. The let statement is used to define the variables where we can store the data. So these are the tabular variables. These variables like orders or customers have the table data. The data table has few attributes, the properties like the order ID, which will have the integer number as you see 1, 2, 3, 4, 5. Then the customer ID, which is also an integer number 101, 102, 3, 4, 101, and then 104. We have some duplicate data as well over here, duplicate entries also over here as you see, or repeating you can say, to understand the deduplication also in the join types. Then we have the customer ID, that is integer we have seen. Product is a string value that is wrapped in this double quote or single quote you can use. And then amount is real. Then I have this second table which has three properties in it. Number one, customer ID, which is integer. Next is name, which is string. And then we have age, which is an integer. Then I will query the both of the tables using the tabular expression. So my first tabular expression is to call this orders table, this table. Then I will make this data flow to the next operator, and my operator is to join. I will join this table with the another table that is for customers. On is mandatory, where I will have to specify that on what key I want to join. For example, I am joining these two tables using the key that is customer ID. So if we look at this customer ID, we have the customer ID property, which is common in both of the tables. I have this customer ID here and I have this customer ID here as well. In both of the tables, I have it. If I execute this, then what comes here is, let me select all and run this query. What I see is that the customer ID, order ID is 1 and 2, and then the customer ID is 101 and 102, I see. So 101 I can see here, and 102 I can see from here, because it was based on the customer ID. So what we found matching is these two, because in this 105 is not matching to any of the record over here. That is why it has been removed from this result. So as we have seen that it is looking for the matching properties while we have the customer ID 101 and 102. But one thing you may have noticed that for 101 it has taken one property or one key, that is the one row, that is the laptop. This is for the laptop, and this is 101 for user allies. Here we see the 102, whereas this 101 for headphone is missing in the orders list. Why? Because inner unique is the default method, which I mentioned before a while, which means that it will look for the matching properties from here, from the left side table to the right side table, and it will go with deduplication. So if there is any duplicate entry, so that will be eliminated, that will not be included in this. That is the reason that this 101 is not included in this result. So this is the inner unique. Now let us make it a typical inner, where I want to involve the matching properties from these tables, from the left side table especially. So kind is actually the optional operator here, join kind, where I can define that it is inner unique, which is the default one, which I mentioned earlier. So if I run this, here you will see, I need to select the query and then run it. Here we see inner unique, and it is the result that we have seen earlier, that one of the key taken from here is this 101, and then the other one here is 102, because it was also matching. But from the left it is because inner, it means the left side one, we are saying that it is unique looking for. So 101 is not included, this one is not included. But if I make it, let's say, inner, now let's see the difference here. So the difference comes here is that I will see the another 101 property as well, and I run this query. Here I can see that this 101 for the headphone also has been listed this time. Now what about this the another record type that we have here? We have seen this user allies twice. We see that, okay, so age is 30 because it was the same thing. So customer ID is 101. So we can see the two records coming up over here, because this time it is not doing the deduplication. Well, this is the inner unique, which is the default mechanism, but then we have the second method, which is inner. If this discussion is, or explanation is, a little bit overwhelming, then I will share a link with you guys in the description of this video, where from you can look for the details of all the different join operators. So here is the image that I shown you through the slide, and here is the explanation of each of them. The one that we have seen so far is inner unique. So if you look at the schema of this, all columns from both tables, including the matching keys, will be there. That is the schema. And as far as the rows are concerned, so all deduplicated rows from the left table that match rows from the right table. So let us compare it with this, that whether it is in the same manner or not. So if I go with inner unique, I select the query, I execute that. Then if I look at the schema, so I can see order ID, I can see customer ID, I can see product, I can see the amount, I can see the age, name. So in this we have the customer ID, name and age. So customer ID, name and age, the three things have been included. In this order ID, as you see, customer ID is here, product is also here, and amount is also here. So it has included all the properties from both of the tables, from the left and right. So that was the schema, all columns, all properties of both the tables. Then in terms of rows, the all deduplicated. So this is something that we need to look for, that deduplicated rows from the left table. So from the left, it will be deduplicated, that match rows from the right side. Okay. What if there is a there is a duplicate row in the right side table? For an instance, if I go with this one more entry and I go with this 101 and I make it, let's say, Alice, and then I make it 28 and then comma. And now if I run this query, this entirely, so you will see that this 101 third record has been added here because it is looking for deduplication from the left side, okay, not from the right side table. So that is why it has been included. So that is the idea over here. But when I say inner, so here we go, and this is inner, and excuse me, I run this way. So it has included the left side only matching rows from both of the tables, okay, from the left and right. And in the left, if there is any duplicate entry also, that is there. So in the left there is duplicate, or on the right there is a duplicate that has been added over here. Let's keep this table a little bit short to understand it easily. Then we have the next join kind, that is left outer. If you look at this example over here, so left outer, we are saying that all the records from the left will be included. Okay, if we look at the schema, so all columns from both tables, including the matching keys, will be there as well. So matching keys will also be added. It's left outer, so all records from the left table, regardless what records are these, they match or not matching, and only the matching rows from the right table. So for an instance, here I have this 101 matching, 102 matching, okay. 104 is not matching, but you will still see that this 104 will be coming up over there in the records if I go with this left outer. So let's change this kind to left outer. We will see rest of them also that have been populated here, semi, NT. I execute this. And here this time you see 104 has also been included from the left side. So from the left it will include all of them, but not from the right side. From the right side only the matching one. 101 and 102 have been added. So 101 and 102 have been added from here, from the right side. But if we look at this 105 for Charlie, that's not included. So this is from the left side, all of these records are, or all the rows from the left table are included, and from the right side only the matching one have been included. Then the same thing we have right outer. If I want all the right side one, so right side records I have 101, 102 and 105, and only the matching one from the left, so which will be 101 and 102, because 105 is not here. So from the left 105 will not be there, of course. So this is right outer, just the reverse of this direction of the table, we can say. So this is right outer, and I run this query this time. So I'm expecting that this 105 should come up over here. As you see from the right side table, 105 has come up. but this 104 is not this time. So this is right outer. So all records from the right side and left side matching one will come up. Then we have full outer. So all columns, if we look at the schema from both tables, including the matching keys, and all records from both tables with unmatched cells populated with null. So records will be all of the records from both sides, and if there is anything which is unmatched, that will be empty. So this is the full outer we can do to merge the data from both of the tables, matching or not matching regardless. So we will be seeing the 104, we will also be seeing the 105. For 105, if we don't have the data, let's say for this 105 we do not have any data in the orders list, so for that customer we don't have any data here. So for 105 the orders list is empty, it's null, but the user has been added, 105 record has been added, and you will see that 104 will also be added. So this is 104, and for 104 this is the data, and because there is nothing in the right side table, so that has been left null. Same thing is with 103 as well. So 103 is here but not here, so that's null on the right side. So this is the full outer. Now we have left semi. What is left semi? All columns from the left table will be added. Okay, regardless they are matching or not matching, so they will all be added. And then all records from the left table that match records from the right table. So this will include the all records from the left table that match the records from the right table only. So if I do this left semi, so what I'm assuming or what I'm expecting with this left semi on the customers table and on customer ID, I select this all. So left semi, we are saying that all records from the left that are matching, as you see here, left semi, all records from the left table that match records from the right table. And if I go with this, so all records from the left that match with the right side one, so we see 101 over here, and then we see 102. We don't see the 105 in this list, and if I run it, so this is 101, 102, and then because we have one duplicate entry also over here, so this is another 101 in this case. So that's what we have from the left side. And if you are comparing it with the, let's say, inner unique, because in inner unique also it was like that, these properties matching with the right side, but the deduplicated one were listed in this inner unique. Here we go. If we look at this, so all deduplicated rows from the left table that match rows from the right table, it was that. So it looks almost same, but that is not the case. You see in this table the right side data is, or right side table is not included. I do not see for 101 name of the users, so I don't see Alice, I don't see Bob, I don't see the 101. Okay, that's fine, the same repeating user. So right side records are missing, only the left side records are there. So this is the left semi. Then we have the left anti. So we can reverse this logic. So left anti and left anti semi also we can do. So left anti, oops, let me select all and run it. So this time the 103 and 104, that does not match actually, so that has been taken from the left side table because we are saying anti. Okay, so in semi whatever was matching with the right side was taken from the left table, but this time what is not matching with the right side, that has been taken, so that's left anti or anti, whatever you pronounce it with. Then we have right semi. In the right semi, this logic is towards the right side, then we have right anti to reverse that. So whatever we had left with left semi, now the logic applies to the right side table. So right semi, which means that anything that is matching from the right side to the left will come up. So 101 and 102, I'm expecting these two records with Alice and Bob. I'm expecting them here. And this is my query. I execute that, and now I can see Bob and Alice, and then I can see their age, but I don't see their orders. This data is not included. And if I go with this right entity, so can you suggest what it will come up with? If you can put it in the comment. I'm going with right entity. In right entity, actually this will take anything that is not matching with the left from the right side, what is not matching to the left. So 105 is not actually, so in that case it will come up with this Charlie with this record. So I select this query and I run it, and here we go. So I can see this record from here. So this is how we use this join operator, and we have the detailed description of each of these operators. You can spare some time in case you want to spare more time into this, like into the schema of each of these and the records, the rows that will be collected by each of them, with some examples you want to take from there. So you can look at this in much more details and practice a little bit to be comfortable with the join operator in the KQL. This will be quite helpful when you will be performing the monitoring, or you will be performing the correlations between the two events within the Microsoft Sentinel Log Analytics workspaces. Well, this brings to the end of this tutorial on the KQL join operator. I hope this was informative to you. Thanks for watching, and do subscribe the channel if you have not subscribed it yet.